Okay, so I accidentally clicked stop, so it's fine. We're gonna make like 2 chapters of sensitivities. All right, so now what's gonna happen if you mismatch? You're gonna have a transfusion reaction, which will amount to hemolysis and breakdown of red blood cells and kidney failure, blah blah blah, all kinds of stuff. Not good. Does that make sense? Now, another issue with the blood is so-called rhesus conflict. Ever heard about rhesus conflict? So what is rhesus factor? So rhesus factor is the surface antigen, which is, listen up, independent of this. Okay? So on the surface of red blood cell, you may have so-called D antigen. If they have D antigen, they are Rh plus. No D antigen, Rh minus. Does that make sense? Now look. I am blood type O, rhesus positive. What does that mean? Look on the board. Do I have either A or B or both? I do not. These are my red blood cells, right? But I do have D antigen. So this is actually my red blood cells. Am I clear? If you are AB Rh positive, then your red blood cells are going to have A, B, and D antigens on them. Is that clear? What's important to understand, there are no intrinsic antibodies against D antigen. Does that make sense? Like, if you are Rh negative, there are no antibodies against D antigen in those people. Now, listen, what's going to happen? Look, if these cells from Rh positive individual will end up in that person. That person's immune system, does it know D? No, it doesn't. So that person's immune system will mount an immune response against D antigen. Does that make sense? Usually on the first administration, nothing happens. But if this person will receive another transfusion from Rh positive donor, preformed antibodies that were formed during previous erroneous transfusion, will attack the new batch of cells, and there will be a full-blown hemolysis. So in a pure sense, the truly universal donor, absolutely universal, is someone who is O, rhesus negative. These red blood cells can go into anyone. Does that make sense? Truly universal recipient is AB, rhesus positive, because they can receive any type of blood. Clear? Rhesus conflict refers to the rhesus conflict between the mother and the fetus. So imagine a situation when you have a mother and a fetus separated by placenta. This line is placenta. Mother is Rh negative. Fetus is Rh positive. Okay? We're good? Now, do fetal red blood cells reach mother circulation? They don't. Placenta separates bloods of fetus and mother pretty well. Am I clear? So red blood cells stick around here. They're perfectly isolated. During the delivery, when placenta detaches, some of the red blood cells from the fetus end up in the maternal circulation. Maternal immune system, does it know Rh? No, it doesn't. So what does that mean? It results in the formation of anti-Rh antibodies. Are you following me here? Now remember, when does it happen? It happens during delivery, right? It's not first or second or third trimester. It's a delivery, okay? You with me so far, right? Now, those anti-Rh antibodies, are they dangerous for that particular baby? No. Baby's delivered. Baby's like gone, right? Baby's detached from the mother. So mother has antibodies, but certainly they just hang around. Make sense? So here's what's going to happen when mom is going to be pregnant again. So mom is pregnant again. She's still Rh negative. Okay? Second baby is Rh positive. Those are anti-Rh immunoglobulin G antibodies. Can immunoglobulin G cross placenta? Sure. And here's what's going to happen. This immunoglobulin G from the mother will cross the placenta and will attack fetal red blood cells. Are you following me? And baby will develop what is called a hemolytic disease of newborns, or erythroblastosis fetalis. And that's a bummer. Does that make sense?
What happens?
Kidney failure, blood vessel occlusion. Like, basically, baby starts to develop hemolysis. Massive hemolysis. Are we clear? Now, what do you do? Like, how do you prevent this? Bless you. Let's go back to square one. We in this situation, there's no delivery yet, right? No delivery. So what you do, you take specially designed antibodies. They're called ROGAM. They are anti-Rh antibodies. Okay? They are artificial, don't get me wrong. And you put those antibodies into mom. Are you following me? These antibodies, why it's important that they are artificial? These can't cross placenta. Am I clear? So they hang out in the mom. Then, look what happens. Delivery happens. So baby's red blood cells try to get into mom's circulation, and what do they encounter? They encounter the antibodies that will bind them, check it out, and will prevent these red blood cells from even being recognized by mother's immune system. You see that? They will work as a shield, basically. And right now, to my knowledge, because I always tell students that there are certain things that I'm definitely not qualified to talk about, and it's pregnancy and delivery, because it's never going to happen to me, okay? But to my knowledge, during pregnancy, if mother is rhesus negative, which is very easy to check, she receives ROGAM antibodies automatically. Nobody looks at the baby because, like, are you going to poke it with a needle, right? So just gets ROGAM antibodies. If baby turns out to be rhesus positive, great, it worked. If baby turns out to be rhesus negative, not a big deal. Every pregnancy, okay? Good? Moving on. Questions on this one? Okay. Let's squeeze type 3. Well, yeah, let me get rid of that stuff. So what is type 3? Type 3 is really simple. Immune complexes. IgG plus antigen. Antigen is self-antigen. So this is the classic immune response, right? Autoimmune disease. Look at this. So the immune complexes are formed they go mostly into the epithelial tissues. These immune complexes attract macrophages and produce local inflammation. Inflammation in macrophages result in the tissue damage. An ultimate example of type 3 hypersensitivity is systemic lupus erythematosus. Look what happens. Let's take a look at different epithelial tissues. If it's in the skin, it will manifest as psoriasis. If it's the epithelium that lines up the blood vessels, vasculitis. If it's epithelium of the kidney glomeruli, glomerulonephritis. If it's the epithelium of the synovial membrane in the joints, synoviitis, and arthritic manifestations. Does that make sense? Good. So basically, destruction of basement membrane and attack on the immune complexes in the basement membrane, in the epithelium. Good. Finally, type 4. Delayed. And it's delayed because it's cell-mediated. Okay, so here's how it works. You have first exposure to an antigen. Okay? And this results in T-cell responses. So essentially you mount antigen-specific T helpers and cytotoxic lymphocytes. Now, does anything happen? Does anything happen after first exposure? Like, do you have any manifestations? Most often, no. First exposure just primes your immune system and creates a pool of memory T helpers and cytotoxic lymphocytes. Is that clear? Then you get second exposure. Which results in T-cell activation. And if you remember what we were talking about before, that T-cell activation, okay, cytotoxicity, and macrophage activation, because CD4 T cells, T helpers, are really good at macrophage activation. Am I clear? Does that make sense? Now, this is a really interesting story. So if you look at it, this is what happens in TB test. Okay, if you are exposed to tuberculosis, let's say you're a healthy individual, you get exposed to tuberculosis, okay? Your immune system quickly smashes it, but it gets primed by tuberculosis antigen. Okay? No. Let's ditch tuberculosis. Let's talk about poison ivy. Same mechanism. So you encounter poison ivy. You touched it somewhere in the forest. You didn't know that. So your immune system, for some reason, and in some people it's going to work, in some people it's not going to work, but your immune system, let's say, it's first exposure, mounts T-cell responses against poison ivy. I don't know, you washed your hands, so it went away really quickly. But right now, you have specific helpers and cytotoxic lymphocytes that are primed against that poison ivy antigen. With me so far? So you go in the forest, and you get a second exposure. This time, they already primed. And in a couple of days, all those T-cells, along with macrophages, will migrate to the site of your exposure. And what are they going to do? They're going to start clearing an antigen. And where is this antigen? It's in your skin, which means we're going to get rid of basically skin. And you have these massive blisters. And I'm lucky, I've never had poison ivy reaction. My wife did have. I don't know about you. not only your skin hurts, like it hurts, it itches, it looks awful, those blisters. You feel like crap. Like you have fever. Because it's a local inflammation. All those, pyrogenic substances go into the circulation, you have fever, you myalgia, arthralgia, you feel terrible. Okay? Does that make sense? And basically the only treatment is broad spectrum anti-inflammatories like prednisone. You just take steroids just to dial it down. It goes away eventually. But it lasted like before, because she thought, oh, it's going to go away. A week, it was really bad. It was really hurting. And it took a while for her to completely clear it up, even on prednisone. That make sense? Questions on this one? Okay.